Let's try a more complicated example of a DFA. Let's imagine we want to create a DFA that would recognize any decimal numbers that are divisible by 3. We're going to assume that we're dealing with non-negative integers in this case. This is more complicated for a couple of reasons. First, our alphabet has expanded. Instead of only having the characters 0 and 1, now we have the digits 0 through 9 to consider. Second, it's just, in general, a more complicated problem to think about. There is one thing to help us here, though, and that is that we know that if we add up the sum of the digits of a 3-digit number, that is also something that is divisible by 3. So if we can somehow keep track of the sum, or something about the sum of the digits as we're reading them, then this could help us solve this problem. As with all DFAs, we have a start state to begin with. So I'm going to create a start state. To make this problem a little easier to deal with, I'm going to assume that we will also accept the empty string. So the empty string being accepted means that if there was nothing read, then that would be an acceptable string in this case. Anytime the empty string is allowed as a valid string, that means that our start state is also going to be our final state. So I'm actually not going to label this as a start state. I am, however, going to designate it as an initial state, or a start state, but it's also going to be a final state, because if we read nothing, then that's an acceptable string, and this is the only way to really deal with this. Rather than labeling it a start state, what I'm going to do is I'm going to set its name to be mod 0. And what this indicates is that if I take the number and I divide it by 3, then its remainder is going to be 0. And that's why I'm designating it with this name. Now I want to start to think about the digits 0 through 9 and where that takes us in our DFA. If I read the digit 0, then that's a number that is divisible by 0 if I read just that single digit. So the number 0 is just going to take me back to this state. If I read the digit 1, and it's only 1 alone, well, that's definitely not a number that's divisible by 3, and so I need to introduce a new state. So I'm going to introduce a new state, and I'm going to refer to this new state as my mod 1 state, which is going to be any number that when I divide it by 3 has a remainder of 1. So I can get to this state by reading a 1. I could also get to this state by reading a 4 or a 7. Any of those digits would get me there. What happens if I read a 2? Well, if I read a 2, then that's going to be a number that is not divisible by 3. And if it's a 2 by itself, then I end up having a number that when I divide it by 3 has a remainder of 2, not a remainder of 1. So it's not appropriate to send it to this state. So I'm going to send it to a whole new state that I'm going to identify as being a number that is divisible when divided by 3 has a remainder of 2. So I'm going to set the name of this state to be mod 2. Now I can get to this state on a single digit by reading a 2 or reading a 5 or reading an 8. Any of those digits would get me there. Now if I read 3, well, that is a number that is, if that's the only digit I've read, is divisible by 3. So reading a 3 would keep me in this state. Reading a 6 would keep me in this state, and reading a 9 would keep me in this state. So now from the start state, I have transitions for all of the digits, all of the 10 digits, 0 through 9. What happens if I'm in this state right here, the mod 1 state? And now I have to consider the 10 digits that I could possibly read at this point. Well, if I read a 0, then I would take a number that was, when I added up the digits, was when I divided by 3, has a remainder of 1, and now I've just added 0 to that sum, and so it doesn't change the result of the remainder when we do the division. And so I end up staying in this same state here. That's going to be true for when I add 3 to that sum, or when I add 6 to that sum, or when I add 9 to that sum. In all of these cases, I end up with a new sum that is still, when I divide it by 3, going to have a remainder of 1. For example, if I have a sum of 10, which is when I divide it by 3, has a remainder of 1, and I add 6 to that, then I get 16. 16 is a number that, when I divide it by 3, also has a remainder of 1. What if I'm in this state and I read a 1? Well, let's think about a specific case. Let's think about the case where I'm in this state because I have read a 4, and now I read a 1. The sum of these two numbers is now 5, and now we're looking at a sum that is, when I divide it by 3, has a remainder of 2. Well, I have a state that handles that case where I've got a number that is, when divided by 3, has a remainder of 2, and so I'm going to make a transition in this case here. So I'm going to move from this state where my sum had a remainder of 1 when divided by 3 to a state where my sum now has a remainder of 2 when divided by 3. In the same way that we would transition a state here for a 0, a 3, a 6, or a 9, I transition from the mod 1 state to the mod 2 state on either a 1, a 4, or a 7. Now what happens if I read, I've handled the situations where I've read a 0 or a 1, a 3 or a 4, a 6 or a 7 or a 9. What happens if I read a 2? Well, in that case, I would have been in this state because my sum when I divide by 3 has a remainder of 1, but if now add 2 to that sum, I'm going to end up with a remainder of 0 when I divide by 3, and that takes me back to this state. So on a 2, or a 5, or an 8, I end up back in this state. Similarly, I can go through all of the cases for the mod 2 state. If I read a 1, that's going to take me back to the mod 0 state. If I read a 4, or if I read a 7, all of these cases would take a number that previously was mod 2, and now I've added something that has a mod 1 value, and it's going to end up being a mod 0 value when I divide by 3. And finally, from here, if I go back to the mod 1 case, where if I take a number like 2 and say add a number like, well, add 2 to it, then I end up with the number 4, which is, when divided by 3, has a remainder of 1. And so on 2, or 5, or 8, I end up back in that state. Finally, to make things complete, from here, if I read a 0, a 3, a 6, or a 9, I end up staying in the same state. So here we have a DFA that will accept strings that are decimal numbers, that are non-negative integers, that are divisible by 3, and will reject anything that is not divisible by 3. You can convince yourself of this by trying a few examples and making sure that you only end up in the start/final state for those numbers that are divisible by 3, and end up in one of the other two states for all other numbers.